This is a revision video about transformers, which is P1, the electricity module. So let's get straight in. We live on a giant electrical circuit in the UK. It's called the National Grid. If we do a quick sketch of the UK, very correct. What you don't want is you don't want each power station directly powering the houses around it, because if one goes down, you're in trouble. So the UK is connected up into a huge circuit, and we call that the National Grid. Now the problem lies with that is the distance involved. If we take a quick look at a little video now to our idea of a national grid, it's one actually interdispersed with power stations and transformers. So over here we've got our power station at 25 kilovolts. I'm sorry it's a bit pixelated. What we want to do is we want to actually step it up with the transformer to 400,000 volts. We can transmit that very weak current but very high voltage very far long distances. Then as we get closer to where we want it to be, we step down to according places. Well done. You then step down until it gets down to your house of 240 volts. And if you look in your house, you'll actually see that most things you plug into your mains has its own transformer, stepping it down to 12 volts or even 5 volts in the case of your phone. Now, working out the change in voltage, it's a really simple relationship. If we look at the side going in, we will call that the primary. The side coming out, we will call that the secondary. The coils we will call N. So this side is NP, number of coils on the primary. This is NS, number of coils on the secondary. We have a voltage going in, let's call that VP. We have a voltage coming out, VS. And what we can do is we can look at the relationship between the number of coils and the voltages, and it's quite a simple one. So let's give it a go. Say we take number of coils on the primary, 10. Number of coils on the secondary, 20. Put the voltage in and we'll keep it really simple, 1 volt. What we see is, in an ideal world, the voltage of the secondary is 2. And by now you're thinking, well, this is a doddle. Easiest way to show it is we've gone from there to there times 2, so we go from there to there times 2. Now, the numbers won't always be this easy, so we can write it out as an equation, and it can be written as NP over NS is equal to VP over VS. It's just the ratio between them is the same as the ratio there. This works if you want to go from a small primary up to a large secondary. In that case, we've stepped up. It's a step-up transformer. But we can do the same. We can take a large number of the primary and we could go down to a small number in the secondary, and in which case we have a step-down transformer. Colour those in, red, step up. So the one that you're plugging your phone into, you're charging your tablet and plugging your PC into, is a step-down transformer. They're dotted all through your house, because if you plug the 240 volts in straight away, you'd get a nice little fireball. Anyhow, I hope that helps. Any questions, leave it in the comments below. Bye.